Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video we are going to explore one of the very interesting application of LLM, and that is in AI text summarization. Okay, so you can use LLMs to summarize large documents to provide precise summaries. Suppose you are having a very huge document and you don't have that much time to go through that, and if you want to get the summary information out of it, that time we can take help of these large language models. For example, a financial analysis system may involve analyzing hundreds of pages of earning documents of a company. So here suppose we are having a company. The companies might be having multiple sources of earning. Now each documents will be very lengthy. Going through all these documents quickly is a very tedious process. But if we can get summary of all this using large language model, that will basically be helpful in taking further business decision that which particular earning model is beneficial, etc., etc. So that's what is written here, that you can use a large language model to summarize the key aspect of the earnings, enabling analysis to make business decision. So here I just explained one particular use case of text summarization. There can be various other application as well. And now let's try to understand how we can perform text summarization. So obviously we can take help of prompt engineering. We can put the prompt like this way, provide a short crisp summary for the below text message whatever you are provided, and then we can provide our particular text information, and we can hope that using that particular prompt the Bedrock or any GenAI model will able to provide us that particular summary. So basically I am trying to say large document we will be having. We will pass via our LLM model with a prompt. So here large document plus prompt will be feeding to LLM, and we can hope that the LLM can provide us the summary, right? But in this particular simple approach, there is a very big problem, that is context window. In our previous video, while discussing the fundamental concepts of generative AI and AWS Bedrock, we discussed in detail that for each model we are having a context window. Beyond that particular window, the model cannot remember the information. Now suppose your document is very big. So if you pass directly that particular text information to any LLM model, it might happen that due to very high length, the number of tokens may exceed the expected context window, and as a result, suppose the model will able to only remember this much part. This particular part it may forget. So that way whatever summary it will be generating, that will not be very accurate. So this particular approach, although very simple, but this is having a major drawback that it might not work well with large documents. So we need a better approach which can handle such situations. And there comes our hero algorithm in the big data world, that is Mapreduce. So here I will just give you a brief glimpse or recall of Mapreduce algorithm, because for text summarization to resolve the problem what just now we discussed, Mapreduce can help us in one way. So in our typical Mapreduce algorithm, whatever we study in big data process, what we do, it is having certain steps like splitting, mapping, shuffling, reducing, and final result. Consider a typical example of word count problem. Suppose we are having a text called deer, beer, river, car, river, deer, car, beer. So in this particular text document, we need to find out for each word what is the frequency. For example, beer, this particular word is appearing here once and here once. So beer output should be 2, right? Similarly, car 1, 2, 3 times appearing. So car should be 3. So in Mapreduce world, what we do? First we split this particular bigger text document into small chunks, and that can be based on new line character or something. That step is called as splitting. Once the data is splitted, we basically send them to different nodes to compute those in parallel fashion. For example, here deer is appearing one time, beer is appearing one time, river is appearing one time. Here car, river, so car 1, river 1. Like that way, we basically map for each word one value we map, right? Now as part of next step in the shuffling layer, what we do? We basically group the similar keys related items in one single cluster place. For example, let's consider all the beer related words will be coming here. So this beer will go here, and apart from that we were getting beer here. So from here one particular beer value will go here. right? So beer grouping is done. Similarly, card is appearing in this particular cluster 2 times and here in this particular cluster 1 time. So all these 3 card we will combine here, right? So in the shuffling phase, in simple words, what we are doing, we are regrouping different clustered elements based on the similar keys, and then on this we apply reduction. Like we basically apply sum of all these elements. So beer is appearing 2 times, card is appearing 3 times, beer is appearing 2 times, and river is appearing 2 times. So here in reduction phase, basically we have taken sum within the clusters whatever we have got after shuffling, and then we combine and we get the final result of counts of different words in our input text file, right? So this is a typical MapReduce algorithm where map and reduce phase plays very vital role. So that particular same concept we can basically utilize in text summarization. So the approach will be, here I can write large document. Okay, so what we'll do, first we'll split that particular document into multiple chunks. So here I can write chunk 1, here chunk 2, and here chunk 3. Okay, each chunk should be within the limit of context window. Now on these individual chunks, what we'll do, we'll apply text summarization using prompt engineering. So here I can write text summarization using prompt engineering. Okay, so TS plus P on chunk 1, similarly text summarization and prompt engineering, using that we'll get the summary for chunk 2 also, and similarly for chunk 3 as well, using prompt engineering and text summarization we will get the summary of chunk 3. So here summary of chunk 1, summary of chunk 2, and summary of chunk 3. That many number of summaries we will get, which is equal to total number of chunks whatever we got after splitting, right? Now these summaries are chunk level, but we need document level summary. So what we will do, we will combine all these summaries, and here I will get a big summary list, okay, which will be containing the elements like S1, S2, S3, so on. These particular summaries we will pass via prompt engineering and text summarization. Like in prompt engineering we can write, like you are given a set of summaries for a document, create a summary from the provided individual summaries which will contain most of the important and valuable information, right? So from this list of summaries we will finally generate our ultimate output summary. Okay, so in this way, the context window problem what we were earlier facing while providing the complete document at a single shot, that will be resolved. Because here if you consider in last stage, here we are passing small summaries, and that group we are passing. So obviously that will not exceed the context window. And in this particular layer where we are applying one layer of summarization on chunks, they are sufficiently small volume, so those chunks will also not exceed the context window for that particular model. So that way nowhere it will exceed the context window and it will not lose any vital information while summarization. And I hope you are getting it, that it is kind of giving the feeling of MapReduce algorithm only what just now we discussed or what we use in our big data world. So this is also called as MapReduce summarization. First we split, then on individual chunks we apply summarization, and then we combine all those summarization in a list. We pass that list to perform summarization on top of that, and finally this way we will be getting output summary, which is basically ultimate summary of a large document. I hope you understood this. Now without any further delay, let us directly jump into the implementation section. So here I will go to my Google Colab, and let me first show you that particular document for which summary I want to get. So here this is a document related to UP government steps in inclusive development for Uttar Pradesh. It contains different points like expressway development, then increasing air connectivity, health infrastructure, apart from that film city development. So suppose for this particular PDF file we want to get the summary, right? So as a first step, what I will do, I will upload this particular PDF document in my Google Colab notebook. Click on OK. And here this particular document is uploaded. For this particular implementation, we need these modules, Boto3, LangChain, PyPDF. Obviously, I hope you are getting to read the PDF files, unstructured PDF and LangChain community. So I will just do a pip installation on that, and here I am inputting all those things. Now as part of the third step here, what we are doing, we are creating the Boto3 client for our Bedrock, because ultimately here if you see that for individual chunks or for all this list of summaries, we need to get the summary. That time we will pass the prompt and our LLM should work. Now here we are running our code from Google Colab, so obviously from Python if we want to connect with Bedrock, we need Boto3. So that particular Boto3 client for Bedrock we are creating using AWS access key and secret key. Now here def summarizer, this particular function is basically taking the prompt data which will contain the prompt as well as the input text for which I want to get the summary, and here we are converting it to the expected JSON format in which Titan model will take the input data, and then here we are calling our Bedrock Titan text express model using .invoke model from the Boto3 Bedrock client whatever we have created, right? And then here already we discussed, like whenever Bedrock Titan model return the data, this is how we can get our actual required information. That information we are returning. So here I will run the summarizer as well. Now here read PDF and split. So what this particular function will do, this particular function will take the PDF file path and it will split that particular document into multiple chunks and it will return us. Basically this particular phase we will implement using read PDF and split function. So here what we are doing, we are taking the file name with complete file path and we are basically reading that particular data using unstructured PDF loader. So this is nothing but a package provided by LangChain to read PDF files. All we need to do, we need to provide the file path, and using loader.load we can get the data. I am printing the data. This is totally optional. Just I am using this particular line to show you how the data will be getting displayed after loading is done. And here we are calling recursive character splitter. This particular package from LangChain is basically going to help us in splitting that particular document. And based on what it will split. So here I am getting a warning of restart session, so I'll just click on that. So what we are discussing, that how the recursive character text splitter will split the document. Generally we can split maybe based on new line character, that is /n or something like that. Now in this case, recursive character text splitter not only split the document based on new line character, but it has some other list of delimiters also. So here if you check the documentation, here you will get that this text splitter is the recommended one for generic text. It is parameterized by a list of characters. It tries to split them in order until the chunk is small enough. And the list is like this. This is the default list. So first what it will try to do, it will try to split based on 2 new line characters. Then it will try to split based on 1 new line character. Then it will try to split based on space. And then it will try to split based on this kind of empty string. And it will keep on splitting until and unless we are reaching our expected chunk size, which is 400 characters. Here we have configured. Like that way it will keep on splitting recursively, and the order is like this manner. First based on this particular character, then based on this, then based on this, and then based on this. So that's what we are doing here. And in between 2 chunks, we want to make sure that there is little amount of overlap as well, so that 2 different chunks will not be completely out of context with respect to each other. And then we are splitting that particular document. That way, here in this particular function, we are reading the document or PDF file and we are splitting as well. So I will run this particular cell as well. And here I will basically call this particular function, that is read PDF and split. So here what we need to do, we need to provide the path of our PDF file what just now we have uploaded. So here I will do PDF document. So unstructured PDF loader is not defined. So let me see. I'll just rerun these cells. So here you can see this time it is running, and here basically it will read the PDF file and split into different chunks. So here you can see that I can maybe print in a new cell as well. So if you observe the PDF document, here it is like this. So this is our document 1. Each document is basically nothing but kind of a tuple, where first element is page content and the next we are having some metadata information and start index. Okay. Then here we are having our next document or chunk, page content. Similarly here metadata information and then start index. Like that way it is split into multiple chunks. If you want to get what is the total number of chunks, you can easily execute length of PDF document here you will get 20. So here what we have done, we have basically splitted our large document into 20 small chunks. Now what we will do, for individual chunks we will get the summaries first. So here that's what we are doing here. Summary equal to empty string we have defined. We are iterating in the chunk list. We are extracting each chunk one at a time. And here if you see, within our this particular list, here document is one element. Within their page content, here actual information is available. So that's why here when I'm iterating via for loop, I am extracting the page content using i.pageContent, as simple as that. And then here I am providing a prompt that provide a detailed summary for the chunk of text provided to you. And here I will provide the chunk. So this chunk here we have already extracted from that particular list element that we are providing. And then we are calling our summarizer function, what we have created here, right? This will take our input data, pass via Bedrock Titan model, and it will return us the output. So because here we have written the prompt like this way that provided detailed summary for the chunk, so we can expect that this particular function call will return me summaries of individual chunks. Now as part of the next step, what we need to do, we need to combine all these summaries to get the overall data or overall list of summaries. So that we are doing here. Here I have defined a empty summary, and that we are basically appending in this particular line, summary plus equal to summarizer prompt. So summarizer prompt will return me the summary of individual chunks that we are keep on appending to get the summary list. So once this particular for loop is executed, this variable will contain total combination of all the summaries of different chunks. Now here we are getting the final summary now. So what we will do, we will pass like this way. You will be given a set of summaries from a document. Create a detailed summary from the provided individual summaries. So in this layer, basically we are performing this stage. So here we have passed individual small summaries of different chunks. Now we need to get output summary of document level, right? And then we are again calling our same summarizer function with this particular data. So this way we can implement Mapreduce summarizer for text summarization, and this is a very popular algorithm to get summary of large documents. And here in this case, obviously context window issue will not appear. If you directly provide this complete document and ask like this way that provide a detailed summary, that time there is a possibility that the bigger text might exit the context window, and as a result the LLM may forget some information. But because we have splitted, got the summary of individual chunks, and then those individual chunks again we are passing to get absolute summary, so this time we can expect it will not exceed the context window. And let's wait for some time. You will see that complete summary of overall document will be written. So let us wait for some time to run this particular job. So here now this particular cell execution is completed, and we got the summary of overall document. The Uttar Pradesh government has taken several steps to promote the film industry in this state. It is planning to set up a film city near Lucknow, which will provide a platform for youth to showcase their talent and create films. The government is also providing financial assistance to filmmakers, right? Additionally, states establish film development, right? And then medical colleges in 65 districts, AIMS in Gorakhpur and Raebareli, 22 medical colleges they have established. 38 crore vaccination doses they have completed in COVID. 6.51 crore people have received Ayushman card to avail healthcare insurance covered up to 5 lakh. So whatever this particular document was having, that kind of summary it is providing. So this is the usage of Mapreduce text summarizer. I hope you understood this.